G'day chemistry students. In the next few videos we're going to be focusing on dot point 3.1.3, which is all about different kinds of chemical reactions. So I'm going to be taking 3 different videos to look at a few different types of reactions. These are just broad classifications of different reactions. Today we're going to be looking at synthesis, decomposition, and combustion. Let's get into it. So first off, let's look at synthesis reactions. On the left, what I have is sort of a general reaction equation for how a synthesis reaction sort of goes. So essentially, on our reactant side, we'll have 2 or more compounds or elements, and they will react together to form a new substance. Now, in particular, for a synthesis reaction, we have 2 or more compounds or elements reacting together to make one product in particular. And on the side here, I have a few different examples. So for example, hydrogen and nitrogen can come together to form ammonia, noting that ammonia is made of only nitrogen and hydrogen itself. Magnesium oxide and carbon dioxide can come together to form magnesium carbonate. Carbon monoxide and oxygen can come together to form carbon dioxide. Sodium and chlorine can form sodium chloride. Something to really reinforce as well is that all of these equations have been balanced. So we don't just throw 2 molecules together to make one new one. A lot of the time, these molecules will react in particular ratios to satisfy both sides of the equation, essentially making sure that we preserve our law of conservation of mass. Also keeping in mind as well that we are always forming one product for any of these reactions. Now, it's a little bit wordy. You can go and read this yourself if you would like, but I wanted to show you an example of a synthesis reaction that has more than 2 reactants. Now, most examples of synthesis reactions that you will see will involve 2 reactants forming one product. I guess I just wanted to show you this reaction in particular with a group 1 metal, so that's lithium, sodium, potassium, etc. But it, as a carbonate, reacting with water and carbon dioxide to form a metal hydrogen carbonate. So just an example of a synthesis reaction with more than 2 reactants. Our next type of reaction is a decomposition reaction, and I'm hoping that you can see quite early on that this is essentially the opposite of a synthesis reaction. We start with 1 reactant, and it splits up and breaks down into multiple products. Again, usually you'll see lots of examples where you do have this form AB turned into A and B, where there are only 2 products. However, that's not the entire story. There can be reactions with more than 2 products. I will show you that in a second, but I have a couple of examples here. I'm not going to read them all out like I did for the last one. What I will say though is that you may see something like this in some of your reactions as well, and they didn't occur in the synthesis one. That's not necessarily because it doesn't happen in a synthesis reaction, but just more happenstance. What I want to emphasize though is that anything that exists on the top of your arrows is some other reaction condition that's required to enable the reaction to happen. And usually that's either energy or a catalyst. Now, a catalyst is something that we'll talk about in a little bit more detail further on in this topic. But for now, with these reactions in particular, this reaction requires heat, this reaction requires electricity, and this reaction requires some form of energy in the form of light. Some decomposition reactions don't require some sort of energy source or catalyst, for example, the carbonic acid decomposing into carbon dioxide and water. To build on this, again, another example reaction, you're more than welcome to read this yourself, but this is just a reaction where a decomposition can occur where there are more than 2 products forming. In this example, it's kind of the reverse of the synthesis reaction we looked at before. Here we have a group 1 metal hydrogen carbonate decomposing into the group 1 metal carbonate and water and carbon dioxide, so 3 products there. Next one to look at for today is combustion reactions. Now, there is a general reaction equation. There are a few different ways that combustion reactions can sort of occur. Essentially, you have a fuel and it reacts with oxygen and forms some sort of product, maybe more than one product, usually more than one product, I should say, and heat and light energy is also usually released as well. Now, some important points. The main idea is that for a combustion reaction, oxygen is reacting with something and the reaction is happening very quickly. And on top of that, it requires an ignition source, so some sort of energy to start the reaction. But once the reaction's actually going, the combustion reaction doesn't need further supply of energy. And I guess in comparison, unlike these reactions here that need a constant source of energy for the reaction to occur, this one just needs ignition, and then it will just keep reacting over and over again with any oxygen supply in the air. So there are two main categories of combustion reactions. There's one for organic fuels, some form of what we call a hydrocarbon. We will break this concept down a little bit more in Module 4 and in exceptional detail in Module 7. But for the moment, what I want you to keep in mind is that a hydrocarbon or an organic fuel is something that has come from something living, whether we're looking at something that has been living recently, like wood, would be a fuel or a hydrocarbon that you could use for combustion, or something that lived over a long time and has broken down into simpler organic chemicals, such as an oil or coal or natural gas or something like that. But it can react with oxygen. For the general equation, its products are generally carbon dioxide and water, and again, it will also form heat and light. Keep in mind, there are some different forms of combustion, complete and incomplete combustion. Complete combustion looks like this, where we form carbon dioxide, but in situations where there isn't a ready supply of oxygen, we may be forming carbon monoxide or carbon itself. Again, something that we'll focus on in more detail later on. Some examples of combustion reactions are here: carbon burning with oxygen, propane, methanol, and acetone. Don't worry too much about the naming for any of this, as I talked about in a couple of videos prior. If you're going to be needing to do any reactions at the moment with organic substances, you will need to be given the formula to work with anyway. Also note that all of these equations have been completely balanced to make sure that the conservation of mass is satisfied on both sides of the equations. The other different version or category of combustion is when we use an inorganic fuel. So usually just some sort of element, a metal or a non-metal. My metal example is up the top and my non-metal example is down the bottom. But again, given an ignition and given a fuel source that's either a metal or a non-metal, they can react with oxygen and form some sort of metal oxide or non-metal oxide. Thank you very much. In the next session, we're going to be looking at some more chemical reactions, mostly to do with acids, different kinds of reactions with those. But until then, have a good one.